Good morning, everyone, and welcome to our WEkEO workshop. Today we will focus on monitoring Cryosphere changes. My name is Andrea Carvalho. I'm a training officer at Mercator Ocean International, and I'll be your host for today and tomorrow's sessions. So before we start, I'll just give you a few guidelines for our sessions. We are on Zoom. You can use the Zoom chat for small talk. But if you have any questions related to the workshop and you want to ask any questions to our speakers, please use Slido. We will be sharing the link to Slido on the chat. Here you have the code for the Slido page related to this workshop. So you can also access it via this code if you go to slido.com. And about our agenda for today, we will have a very nice list of panelists. We will start with Christian Florindo from Labilia Earth, who's gonna tell us a bit more about the product WEkEO product catalog, so what you can find on WEkEO in terms of products. We will have Tobias Borch. Sorry if I mispronounced your name. He's a university professor at Gas Institute of Geodesy at the University of Gas, and Francesca Claire Baldacchino, who are going to present some very interesting user testimonials. And Cédric Jordan, user support manager at Mercator Ocean International, who's going to tell you a bit more about the user section in WEkEO, so how you can access the user support. And so without further ado, I will introduce you to the WEkEO service if you're not familiar yet with the service. So what is WEkEO? The WEkEO is the Copernicus DS, so data and information access service. It's for environmental data, Copernicus environmental data. So it was designed to facilitate and standardize the access to Copernicus data and information. So the idea, as I said, is to facilitate the access to Copernicus environmental data. There you will find an harmonized data, so it can be downloaded and accessed in a much easier way. You will have access to a cloud infrastructure where you can run simple analysis and have access to tools. And as a third positive point is also that you have access to a very active user support that can help you in accessing the data, also transforming the data, and any other question you might have. Yes. So who operates WEkEO? The same entities who operate the Copernicus services. If you're not familiar yet with the Copernicus program, I didn't mention it before, but it is a EU program dedicated to Earth observation, and it has 6 different services focused on different axes of the environment. Have the marine, the land, the climate change, the atmospheric, and all these services are operated by different entities, and so WEkEO is also operated by all of them, dedicated to different parts. So as I said, in WEkEO you will find data related to Copernicus land, Copernicus marine, atmospheric, climate change, and emergency monitoring, as well as data related to the Sentinel missions. Sentinel are the group of satellites operated by EUMETSAT, and that contribute to a lot of the EU missions. So how can you access the WEkEO service? At wekeo.eu. There you will have access to all the data. We will talk a little bit more about that later on. Christian will present the catalog more in detail, and Cédric will tell you a bit more on how to access different parts of the website as well. So as I said, like it is Copernicus, it's a place where you can find data related to Earth observation. You can run simple analysis, simple computations. It's also an access to discuss with experts of each of these services if you have any specific question on the different data. So just to highlight the major assets of WEkEO, in WEkEO, you will not find a copy of the data. You will have access directly to the data of each service. The access to this data is harmonized, so it is easier to access each, like the data of the different services. And you will also have, like I said before, like an expert user support, a specific user support per type of data. So you can opt for if you're a beginner, let's say, you can opt for a free plan where you have access to visualize the data, download the data, run simple analysis in a Jupyter Lab, and also have access to the notebooks that are already available in the Jupyter Lab, Jupyter Gallery, sorry. And of course, you have access to the user support. If, on the other hand, you're a little bit more expert and you would like to maybe have more storage or run like bigger computations, you might opt for a paid plan. You can have all the different plans here according to your needs, storage or CPU capacity. You can also check them on the website. So basically, as I said, like a lot of it can be accessed for free. It's really mainly the computing capacity that will make a difference. And yeah, I didn't mention, but most of these packages you can try it for a few months and see if that works for you or not, and then opt for a paid plan or not. Tomorrow we'll see a little bit more about the Jupyter Lab, but you can have access to a Jupyter Gallery and also open your data, visualize it, transform it. And you can also have access to the GitHub where you can discuss with other experts and learn. There's a lot we have already developed to the different Copernicus axes. So you will find under the Jupyter Gallery a bunch of notebooks where you can open and you can run and learn from these examples we have there. So the access to the virtual machines are paid, but if this works for you, you can also have access to that, and we can also cater your needs. So depending on what you need, we can also adapt it to that. So Cedric will tell you a little bit more of that, but you have a fantastic team at your service that will be quite responsive and try to search for the answers you need. On YouTube, you can also find previous workshops like this one, and also short demonstrations of the viewer or on how to access Jupyter Lab, etc. So you can find all these resources over there. And thank you for your attention. This was an introduction to the WEkEO service. I hope this was clear. And now we'll get into the product catalog. So what you can actually find in WEkEO with Christian Florindo. Whenever you want, Christian.
Thank you, Andrea. So hello, everyone. I'm just going to quickly share my presentation. There we go. So just to start, I just want to first introduce that in the catalog for WEkEO, there are more than 300 different data sets, and all these data sets have a plethora of variables as well. But for today's presentation, I've done like a small selection of some of the data sets that could be more relatable or more important sort of for monitoring the cryosphere changes. What I've done is trying to divide those into the different Copernicus services. So there we go. Starting with the land surfaces, just a quick overview of this service. They provide first global biogeophysical products that are related to different land variables, such as the evolution of the land surface. but also there is quite a big focus also in the pan-European domain. Besides that, there's also some focus on different hotspots, areas that are significant due to their environmental challenges. And of course, it's all pretty much related to the reference imagery from satellite data. So in this table, you can find some of the most relevant data sets that you could think of for this topic. Of course, being related to line, you'll see some data sets that have to do. Hold on, I'm just gonna put my pointer. Let's see. Okay, here. Some that have to do with snow cover and ice. So, for instance, you've got the Copernicus fractional snow cover, which has quite a high resolution based on Sentinel-2 data, and just to see what fraction of the land is covered with snow. There's a more a daily product with the gap field, so that's taking more data to try to sort of fill in the gaps to give a more standard product as well. You can find persistent snow areas, so areas that have snow cover for long periods, which are consistently covered by snow, and how they are evolving over time. And again, you've got the same sort of data set, the snow area, but in a polar projection as well, which is quite important for this purpose. Another interesting data set has to do with the ice that you can find on lakes and rivers, again with really high resolution and near real time sampling, and other products that are within the land surfaces are the wet snow based on SAR from Sentinel-1, and also the proportion of or the classification between what's wet and dry snow, which is based on the water content that there's within the snow cover. So just to have an idea of how these data sets may look like, I just selected a quick example. This was a Filomena snowstorm in Spain that was in January 2021. There was a quite an unusual snowstorm that covered half of the Iberian Peninsula with snow, and you can see this with the gap-free snow cover data set, how that sort of snow cover was a few days after the storm, once the skies were clear. Again, this is the same event, but in this case, we're looking at the classification of wet and dry snow, so that you can see sort of which part or what proportion of the snow cover is of one type or the other. On the top right, you can see the data set of the rivers and lakes ice extent, which had a resolution of 20 meters, as you can see here. And these are some lakes in the Swiss Alps. And you can see, for instance, in light blue, what area is covered with ice and which one is ice-free or is in liquid form. So these are just some examples of the products that you can find for the land monitoring services of Copernicus. Now, moving on to the Marine Service, an overview. There's you can sort of classify the different data sets by the Copernicus Marine Service by blue, green, or white ocean, which is more the physical aspects, the biogeochemical aspects, and then the white ocean, which is perhaps the one that is more relatable to this workshop, which is anything that has to do with ice and snow. So moving on to the white ocean, there's different data sets that span from 2 to 25 kilometers in resolution, with different temporal resolutions as well. And they also include different forecasts for the next sort of 10 days at a daily sort of sampling, and also time series that span quite a long time. And you can see all sort of information that has to do with sea ice, concentration, thickness, extent, drift, the velocity as well, but also some on snow, icebergs, and so on, and the temperature of the ice as well. So there's many data sets that are relatable in this survey. So I've selected a few. First, I'm showing some that are sort of global or that are relatable to both poles, both Antarctica and the Arctic Ocean. First, we have the high resolution sea ice, where you can find ice concentration in the ocean. Then ice drift, which is the displacement, how this ice is moving. You can also find the Arctic and Antarctic sea ice concentration, age, type, and drift. You will find a lot of information about not just, also about concentration and drift, sort of what we've seen before, but also what is the edge of where's the edge of the ice and what type of ice that is in different aspects. You can also find, again with SAR, what is the sea ice drift. And finally, what's the global ocean sea ice concentration? But that is a time series that is reprocessed. So they have different spatial resolutions and different temporal resolutions, and some of them might have different sort of similar variables like the concentration or thickness, but they have small differences depending on where they are originated and how they are calculated. Now, some of the Arctic specific data sets, these are only for the sort of the northern hemisphere for the Arctic. So again, we have concentration and the type of sea ice. You can also find what is the temperature of that sea ice with quite a high resolution and daily temporal resolution. There's the sea ice thickness, and this one is calculated by the combination or the merging of Cryosat2 and smooth ice thickness. And again, you have many different data sets that can inform about the movement of the ice, how is it drifting, the thickness, and some that are not just the Arctic, but in this case, you can see different charts of sea ice concentration by well, for Svalbard and Greenland, but generated by the Met Norway and DMI operational sea ice services. And again, we can find information on the concentration of icebergs based on SAR and the sea and ice surface temperature in the Arctic Ocean. Again, I based this table on the more observational data sets, satellite, but just so you know, there's a new data set that is in situ as well that covers the different floats and data that's around the Arctic, but in specific locations like moorings and floats. And there's also model information that can give you a forecast for the next 10 days or so in the different variables. Again, this is an example of how some of these data sets look like. In this case, we've got the sea ice edge, but the Oaks itself. This is a Ross Sea, I think in sometime in early December 2021. And that's the sea ice classification from open ocean, fractured ice, I believe, and then in green it will be like more consistent or thick, well, consistent sea ice, and this is perhaps the formation of the Polania. On the other hand, we've got the Arctic Ocean sea ice and biochemistry analysis and forecast. This is a model. And what we are saying here is the sea ice area fraction, so the percentage of the area that is covered with ice. In red, you see areas that are pretty fully covered with ice. And then in dark blue, you see open ocean, and that is sort of the clearing, the starting of the clearing of the Northwest Passage. On the other hand, we've got information from that same model from the from chlorophyll A, from the biochemistry model. And you can see for that same date, what is the chlorophyll concentration on the bits of the ocean that is open, and a bit also below the ice, and that's model information. Okay, so moving to the next service, the climate change service. So in a global picture of this service, they combine a lot of daily in situ observations from weather station, balloons, long-term series, and a lot of variables. And they also take in satellite information and indirect measurements, and then they also run models to understand, to get forecasts and make projections, and also do reanalysis. So the idea of these services is the goal of this service is to map past, present, and future climate. So some of the data sets that you may find interesting for this service, again, this is only a selection from many data sets, but one of them is the Arctic Regional Reanalysis. Again, you can find information for this reanalysis in different levels. So you can find them on high levels of the atmosphere or model, pressure levels, and also single levels. And this specific reanalysis is only for the Arctic domain, and it has 3-hourly analysis of different atmospheric variables. So another one that you may find interesting is the Greenland ice sheet, which is an annual product which is graded, and it provides velocity data, so you can see how the ice sheet of Greenland is evolving in a year-to-year basis. Following along the same lines, we can find this data set for Greenland and Antarctica, which measures what is the ice sheet changes for both of them in terms of what is the surface elevation of their ice sheet and how that is changing in a monthly sort of resolution. This one as well is quite interesting. You can have the gravimetric mass balance of the Antarctic and Greenland ice sheets. So if you're interested in that mass balance and how the quantity of sort of ice is, how that's changing over time, this might be suitable for you. And then similar to the marine products, we've got sea ice thickness, monthly gridded and monthly products. And perhaps what we're looking before as a picture of the Northwest Passage, if you're interested in the decadal projections in a monthly base of when these passage is going to be available, open, and so on, this data set might be very relatable to you, or very important for you, and it does not only has projections about accessibility, but it also has a lot of variables like what is the duration of the trip, the speed of the ship, the cost, and different ice indices. So it's quite an interesting data set, I believe. And finally, we've got some data sets as well that have to do with glaciers. First, you've got the Randolph Glacier Inventory. So that is a snapshot for the year 2000, and it sort of pictures from different maps, aerial photography, and satellite imagery, what were the distribution of the different glaciers and sort of their outlines or their extent at that time, which is a good starting point to see how they have evolved to now. And then with this second data set, you can see the annual to decadal evolution of the elevation of the glaciers and sort of their mass balance and so on. So these are some of the examples of the data that you can find. I believe not all of the data sets are visible on the viewer. but this is just to give you an idea of what information and what you can do sort of with them. So this is the Greenland ice sheet and our gridded velocity data. So you can see where how that sort of ice is moving. That is the glaciers data set, the second one I was talking about, how they are changing in elevation and mass change in a sort of annual and decadal scale. And again, how the ice sheets for Greenland and Antarctica, how their elevation change rate is evolving, and the Arctic route availability and cost projection that we were talking just a second ago. Another point that I would like to point out is from this surface is that it may not be a data set that is directly related to the cryosphere, but it might be quite important if you want to look at atmospheric variables. But now the ERA 5 hourly data on single levels from 1940 to present is now visible on WEkEO. This is an example of the temperature at 2 meters. And even if it's not a data set directly related to the cryosphere, it will have a lot of variables that might be very important for your analysis. And just to point out, this is quite a recent advancement of WEkEO. We're talking about data that spans since 1940. This example is from February 1st, 1940. And this is hourly data since that year. So that's a vast amount of data that is now directly viewable on WEkEO for all of these different variables, which in my opinion is quite a big advancement, and it's quite useful to sort of tech in the platform. Moving on to the atmosphere surface, it's a global picture of what they do, where they've got global analysis and forecast of sort of weather and climate and every analysis of different gas composition, aerosol, chemical species, greenhouse gases, a lot of different variables of the composition of the atmosphere at different levels. There's also regional analysis and forecasts that are specific for Europe and are more based also on the air quality of cities and so on. And there's also supplementary products and emission-related products, sort of the greenhouse fluxes and the climate forcing and the different variables that are also used to sort of force those models, and then some analysis on the emissions from different fires and anthropogenic sources. So moving to some of the data sets that you may find interesting for your purposes monitoring the cryosphere. One of them has to do with the atmospheric composition of the atmosphere, and you can find things from ozone to different a lot of different types of gases, up to 50 different chemical species, 7 types of aerosols, and different meteorological variables. So it's quite a big data set, this one. You can also find the emission inventories from different anthropogenic and natural emissions. Again, all of these have different scales and resolutions. These data set, you can have the biomass burning emissions. So what sort of emissions have to do with fire and with burning. So you've got up to 40 different pyrogenic species, quite good resolution. Moving on, we also have the EG4 greenhouse gas reanalysis based on containing the variables mostly or principally CO2 and methane. Again, this has like a quite high resolution in terms of time. What else? We've got from the accessory ones, we've got the greenhouse fluxes and concentrations from, I think it's, if I'm not mistaken, with transport models or inverse models. And you can find what are the fluxes, exchange of different gases and their mixing ratios, again, for CO2, methane, and so again, we had the radiative forcings as well, and yeah, some other reanalysis. And if you're interested in solar irradiance, this is a long-time series of the solar radiation that goes from resolution from 1 minute to a few 15 minutes, I believe, 1 hour, and up to a month. So you can find a lot of information, as you can imagine, about the atmosphere composition, about projections, and how, and different model forcings as well. This is, again, an example. I believe this is that first data set that has a lot of different variables. And here I just wanted to show, for instance, this is the total concentration of ozone in the full atmospheric column. So from top to bottom of the atmosphere, what is the composition of ozone? This is Antarctica, and this is the projection for, I think, today, or yeah, is it today or tomorrow? And you can see what is the expected concentration. And I think what points out here is that low concentration that might be related to the ozone layer and the hole in the ozone layer. So if you're doing ozone analysis, that might be an interesting data set for you, but it has all of these other variables as well that you might find relatable. And again, like ERA5, this vast data set is also viewable on the platform, so you can choose your variables that you find more interesting, and you can select the time that is suitable for you. You can have a preview of the data before you download it, or if you just want to have a quick look at the data and you don't need to download it, you can just go to the platform and take it and extract the information that might be more suitable for you. And finally, there's the other service by WEkEO, which is the emergency management, which might not be quite significant for the cryosphere, might not be the most relatable one, but I just wanted also to give you a little bit of information on this. But it has on-demand mapping of different events that are occurring, such as fires, for instance, or floodings, or natural catastrophes. They provide information that help the authorities to sort of manage and collaborate on the mitigation of those. But they also have early warning and monitoring. And what you can find on the platform has more to do with floods and fires. So again, if in your studies in the cryosphere you're worried about flooding or things like this can still be relatable to you. And finally, besides this, there's also the different Sentinel products that a lot of them are used for different products that I've mentioned, but you can also access directly the data from the different Sentinel missions. Sorry, I forgot to mention this and that. Yeah, the river discharge from flooding, from precipitation, but also from ice melt and fire danger indices. So that's everything for me. So back to you, Andrea.
Thank you, Christian. That was a really complete compilation of the interesting data sets for ice studies, I would say. Thanks a lot. I think there was a few people asking for your presentation already. I think those tables are quite useful. And we have a few questions. If we could go to our question screen, please. So the first question for you, how comes that the data from the same source, for example, Sentinel-1, has such a varied range of temporal resolution?
Right. So yeah, that's a good question. So the Sentinel-1 has, of course, their passes, so it has their sort of bands, and the different products are not directly that data onto a variable. They have different types of processing, and sometimes they have different so processing not just in the terms of how that data is dealt, but also how it's merged. And there's different levels of processing. And the more you do, you can find products that are more consistent in space, that cover a large area and fill in the gaps and so on. But of course, that is in detriment as well of the resolution. So depending on how the different variables are calculated by the different centers that sort of produce those data, that means that they have those different temporal resolutions. So generally, when it covers a larger extent and has less gaps and so on, usually it has a longer sampling in time.
Thank you. Next question, how to generally approach finding the right data set in WEkEO for a specific use case? Maybe
Right, so
see a little bit more of that with our user testimonies, but yeah, go ahead if you
yeah, but you
give some
possibly
tips.
will see that. But one thing that I would like to mention is that once you go into the WEkEO platform, the data viewer, you have a really nice panel where you can filter and select following many different aspects from the Copernicus surface, the type of data or the Sentinel as well, originating center, and many variables, whether it's cryosphere or ocean, whether it's global or specific to a region. So you can filter, and there's also a search bar where you can find the information that you're needed. And then once you have a selection, you can sort of investigate the details of each data set and see which one is more appropriate for you.
Exactly, and also on that, tomorrow we'll have our practical session, and the first part of our session is actually the demonstration of the viewer that you are mentioning. So yeah, we'll have a small demonstration on how to access the data and how to pick the right data for your work. Oh, this one is a more general question. Yes, we will share the presentations if it is okay with all the speakers. You will receive an email with a link to all the presentations. And also, there was someone asking about previous workshops. You can have access to the previous workshops on our YouTube channel. If you go into youtube.com, you just search for WEkEO DIS, and you will have access to all the previous workshops. Next question, I think we have access time for one more question maybe. Are there any data sets for land surface or ice surface temperatures, whether infrared or microwave?
Yes, there are. There is for sure the sea and ice surface temperature, which is with METOP and AVHRR instrument, I think. And there might be more, but I would have to check if because there's over 300 different data sets.
Okay. This one. Maybe this one is a bit specific. Okay, one last one maybe. Are there separate glacier data for the Hindu-Kush Himalayan region? How do I access it? It's a bit specific. I don't know if you
Yes,
had one
very,
answer.
very specific, but the data set that I mentioned with glacier data, I think that you can pinpoint to the different glaciers. So it's quite possible that, yeah, there's, I mean, I think you can go down to each glacier, if I'm not mistaken. So I would
Okay.
imagine that yes, but I'm not 100% sure.
Yeah, how about that? Yeah, no worries. Okay.
I don't know
Thank
whether
you.
you can hear me. Yeah, you can hear me.
Oh, yeah.
So I can provide a dedicated answer to that, but it will take a little bit of time.
Yeah.
There is a lot of data set available, and I will also touch upon it on my presentation.
Perfect, which comes right after. So right timely. Great. I think we will stay here for the questions so we can pass on to our next speaker. Thanks a lot, Christian.
Thank you.
And now I'll introduce you to Tobias Bolch, who's gonna tell you more about his use case. The floor is yours whenever you want.
Yeah, good morning, everyone. Well, I'm Tobias Bolsch, or in German, I would say Tobias Bolch. No matter how you want to present me, I'm doing work about monitoring of glaciers, mainly in high mountain Asia, but also in the Alps using remote sensing data. And I will give you a short overview about how we can access and what we can do with the WEkEO data. But first of all, just a little bit of background about myself. I'm actually a physical geography by trainer. I was part of the glaciology group at the University of Zurich, where actually the WGMS, so the World Glacier Monitoring, is located. So I have insights in all the data sets, which are also within WEkEO.
Sorry, Tobias, for interrupting you. We're not seeing your screen. I don't know if you're trying to share.
Oh, sorry.
Don't worry.
I can see.
So on the bottom of your Zoom.
Okay.
Yeah, perfect.
Now you can see it. Okay. Sorry, and thanks a lot for pointing this out. But first of all, it should be larger, right? So first of all, this is the nice title slide. So yeah, well, you've just heard about that I was part of the glaciology group in Zurich, where we worked a lot about glaciers, and I was also involved in the Randolph Glacier Inventory, which was nicely mentioned by Christian. And it was also part of the ESA Climate Change Service, and many of the data sets in the end made it into Copernicus. So I have really insights of what's going on and what is within WEkEO. Since 2023, after some years building up remote sensing at the University of St Andrews in Scotland, I'm leading the working group of remote sensing and photogrammetry at Graz University of Technology in Austria, which is not too far away from Vienna. So why should we use glaciers? Well, it is well known that glaciers are basically a store of ice, which when they melt provide fresh water to the downstream communities. And we tried in an international effort to summarize all the activities and the importance of the glaciers in the different regions. And we looked not only at glaciers, but also snow and precipitation, and really ranked the different mountains, the water towers on Earth. And what you nicely see that in high mountain Asia, basically they are the most important water towers, and this is also the most densely populated areas where the water demand by the people for irrigation and industry is highest. However, but also all the other mountain regions like the Alps and the Rocky Mountains, for example, they really provide fresh water to the downstream communities. So they're quite important. And within the glaciers have a specific role. And what do we know about how the glaciers changed? Actually, since now 2 years, we know how almost all glaciers on Earth changed since the year 2000 due to the availability of elevation models. So basically, we differentiated the elevation models and had the information about where the glaciers are. And with this, we could really calculate how the glaciers changed in elevation in the end in mass. And what you see, let me use the pointer, you see that the red color prevails by far. But there's also some heterogeneity, so that we have higher mass losses, for example, of glaciers. I'm not talking about the two ice sheets, the Greenland ice sheets and the Antarctic ice sheets, where Francesca will be touching upon later on. I'm talking about the mountain glaciers. But you see also some areas where there's some blue color, so not all glaciers are losing mass, but the vast majority. And you're now interested in a specific region. So you can now go to WEkEO, which is really a great data set, great service to search for data. And there was the question. So basically you type in, for example, glacier, then 4 data sets pop up. 2 data sets are of really high importance for the local glaciers and ice caps. So first of all, you see the Randolph Glacier Inventory for the year 2000. Just a side remark, this is RGI 6.0. The next RGI, which is significantly improved, will be released very soon, and which certainly will also make it into the Copernicus and then WEkEO. And then you know where all the glaciers are. You have the information how the glaciers changed, right? So you have all the information needed to really investigate how the glaciers changed during the last decades. Let me now present some specific cases. We're here in the Alps. I'm sitting in Graz, so south of the Alps. We have somewhere, we have Vienna. We have here the Alpine Arc. And when you look at it, you see some white spots, but we are not entirely sure where the glaciers are. So you download the data set from the Randolph Glacier Inventory. You can include it, for example, into QGIS or any other GIS software, and you see quite nicely where all the glaciers are located. And when you're familiar with it, you see the largest glacier of the Alps, which is the Aletsch Glacier. But as we're here in the Austrian Alps, I will focus on a well-known region within the Austrian Alps. And what you see also, we have here all the dots represent glaciers where there are in situ mass balance measurements available. So where really people go onto the glaciers and measure the mass balance. So the ablation, using ablation stakes, and they are digging snow pits to look at the snow thickness, so the accumulation, and also the snow density. When you now zoom into a little bit, and I've here overlaid the outlines of the glaciers on a satellite imagery. So this is simply taken from the Bing satellite service from Microsoft. You see here, this is Hintereisferner, so one of the best studied glaciers in the Austrian Alps. And what you can do, for example, quite nicely with a data set, when you now, so this is a satellite image which is close to the year 2000, where the outline stemmed from. When you now include another data set, for example, available at Google Earth, you see a huge retreat of the glaciers. So first of all, you can simply nicely show to everyone how the glaciers changed in 2 time steps. But when you now want to look a little bit more in detail, you dig into the data set and analyze it, and then you get the information about the mass balance of, in this case, Hintereisferner, and you see it's a fluctuate, sometimes it's positive, but overall the trend is quite negative. And when you then calculate the cumulative mass balance, you see again, it was more or less only slightly negative until the 1980s. It was also a positive phase, but then since 1990, 2000, there was a clearly increase in mass loss. And there you see the different dots. Not for every dot there are these detailed data sets available, but for many, many glaciers, you get a lot of information. There was a question about the Himalaya and high mountain Asia. So this is all the glaciers in high mountain Asia and the available glaciers with in situ measurements. When you look at it, it looks not too bad in the end, but when you look in detail, there are only very few glaciers which have really long-term measurements. And this is Urumqi Glacier #1 in Xinjiang in Western China, and Tuyuksu Glacier in the Tian Shan Mountains in Kazakhstan. And I will show you now here the Tuyuksu Glacier located here. You have a cumulative mass balance, so the measurement started also in the end of the 1950s. It was somehow similar like in the Alps. So first we had a period where there were only little mass loss, but then it increased and increased, and since now we have a steady loss of mass. The glacier which the longest available measurements of mass balance in the Himalaya, you may think about how long it is available. Well, it's much shorter, but still it's available and it's important information. This is actually Shotashigiri Glacier, where the measurements, really in situ measurements, are available since the year 2003. And you see also a clear negative balance. When you compare, for example, these two measurements, you see that for both there was a positive year in 2011, and also 2010 was rather positive, but overall it's a clear negative trend. Well, now there was a question about what is available for all the glaciers. We have this for almost all glaciers now, as I also showed you, information about the elevation change. And this is really based on satellite data, in particular the ASTA stereo data, but also some very high resolution data sets like WorldView or Pleiades. So you can now really click on almost every glacier, not the small ones, not because there the resolution of the satellites are not good enough, but we are improving this information, and soon there is also for all the others will be some data sets probably included also in WEkEO. And let me showcase how it looks like here in the Himalaya. This is the Khumbu Glacier, which is close to Mount Everest, a quite well-known glacier because there are many climbers, mountaineers trek along. And when you now click on it and look into the metadata, you see this one. You have here Khumbu Glacier. You have some information, DM differencing since 1970, so even earlier than the 2000s, then 2002, 2003, and also 2009 to 2016. And you see also here, some of the data sets were provided by myself and by my group. And so I want to showcase you now how these data sets look like in reality, where the data comes from. So we have here different data sets. We have an updated data set, which was recently published by a postdoc who worked in my group, Owen King. We used old SPICE satellite imagery, then aerial images, which were used to generate this famous washburn map of the Himalaya, of the Mount Everest and Khumbu Glacier and Rongbuk Glacier, and most recent satellite imagery like I've shown here. When you look at the glaciers, there's not a clear retreat apart from where it's nicely seen. This is actually a glacial lake, that's Imje Lake, which developed in the early 1960s and increased, and now it is a huge increase. And we touched upon, or Christian touched upon, the hazard data set. So these glacial lake outburst floods are also a real hazard. If they really burst out, there will be a flood wave in the downstream areas, and these occur actually also quite frequently. So it's important to monitor the cryosphere also with the aspect of natural hazards. When we now generate DMs and difference the different time steps, you see the red color prevails by far, and we have a significant surface lowering, which increased until the recent years. And we have overall, just to give you a number, for some glaciers, we have way more than 100 meters of down wasting, so surface lowering of the glaciers. And Khumbu Glacier, for example, lowered by 60 to 70 meters overall. And on average, then something like 1 meter. If you look at this and with the mass balance, you see that if you look at all glaciers, there was a clear increase in mass loss. So similar what you have seen also with the other glaciers, for example, Shoto-Shigri also happens at Mount Everest, but we don't have the in situ data, but we have the data sets from the satellite imagery, which are also then included in WEkEO. And we have also for every single glacier, we have the information. So overall, there's a detailed assessment of mass balance, not only in situ, but it's also possible to do so using remote sensing data. And all the glaciers have increased mass significantly. However, what was also mentioned, when we want to understand why they change, it's important to look at the climate data. That's nicely mentioned. We have in WEkEO now the ERA 5 data, not only from the 1950s, but on the 1940s. But as our data set only starts at the 1960s, the ERA 5 land data monthly is fully sufficient. But for the Alps, for example, we can even go back to 1871 with precipitation data. So this is a rich data set, which is very easy accessible. I just typed in here climate or precipitation, and then the available data set pops up. You choose it, add to the map, and you download the data. And this is what we did in another study, where we looked at different regions and generated a detailed time series similar to which I've just shown you for the Everest region. And here, for example, this is Northern Tian Shan, this is Tuyuksu Glacier, where there's also the in situ data available, which I've just shown you. And overall, what you see, this is 1964, that the red color prevails, and for most regions, there was a clear increase in mass loss. And this is shown now also here. So look at most of the regions, we have an increased mass loss. There was also one reason where we have, for example, balanced budgets, where you've seen, this is here Mustagata, the region where I've shown you the blue circles in one of the first slides. But what I specifically want to show you, when you now look at the mass change and then look here at the for example, summer temperature or summer precipitation or winter precipitation are normally, you can then combine this information with a mass balance. You can understand that almost everywhere there was a clear temperature increase. And actually the temperature increase was, not surprisingly, the driver of the mass loss. And the precipitation is one of the major driver of the heterogeneity of the mass loss. And it's got so warm that even in the regions where we have balanced budgets, the mass loss now prevails. And this can really now very easily be done and analyzed using data sets which are also available within WEkEO. And with this, I'd like to conclude that really WEkEO facilitates the access and working with many different data sets which are relevant to observe and analyze the glacier changes on Earth, but not only the glacier changes on Earth. You can also, for example, look at the sea ice, snow, which was nicely shown, and snow is directly also related to glaciers. You can also include this information when you want to analyze and understand the glacier changes. Yeah, and with this, I'm almost done with 15 minutes, so I'm perfectly in time. Thanks a lot for your interest, and if you have any questions, I will be there, specifically about details and background of the data sets which are related to glaciers. Thank you.
Thanks a lot, Tobias. Yes, we do have some questions for you already. So if you could stop sharing your screen,
Yes.
then we can share. Yeah, exactly. Perfect. I can already read the first one. Yeah, great. So does Copernicus have an autonomous and independent satellite setup for the entire world, including Cryosphere? MODIS seems to be predominant.
Well, this was a question to the general team of Copernicus, but yes, yes. Well,
if you know.
Because MODIS has the major advantage that it's available since 2000, and there is no product available. So this is why it is really used quite a lot. However, there's also on Sentinel-3, for example, a kind of a similar sensor, which can be used in a similar way to generate, for example, snow cover and snow cover extent. And there is a focus of Copernicus or ESA, basically. We have the climate change initiative where ESA data and Copernicus satellites will be used to look at the changes in the cryosphere.
Next one, are there data sets related to debris?
To debris.
Okay,
well,
that's
yeah.
This go ahead if you want.
Yeah. It is available, and this is something, so not all data sets which are available already made it into Copernicus, and then in the end will ended up into WEkEO. So because these are different reasons. One is really the quality check. The other one is it typically takes a while until the data set really makes it into WEkEO and Copernicus. But there are data sets available. We have a global mask of debris cover, like we have the information already in the Randolph Glacier inventory, but there are data sets available also about data thickness. And if you're interested in, I'm happy to share the information directly with you.
Great. And maybe we have time for another one. Yeah,
I'm happy to answer the next one. Do you have any plan for some in situ measurements in some selected glaciers with local partnerships that also supplement remote sensing data sets? Yes, absolutely. So what we do when you know myself, for example, look at my publication record and also of others, we really support local scientists. So also the French team, myself, we work together with Indian scientists, with Kazakh scientists, with Chinese scientists all over, and other scientists to really support them using or starting in situ measurements, and then really compare it also with the remote sensing data set. There is a nice paper by Kazakh partners, for example, about Tuyuksu Glacier, where exactly this is done. When you look at Shota Shigri, which I presented to you, the time series was improved back in time using remote sensing data set. We have also the direct comparison. Yes, we do this, and definitely happy also to support local partners. I think this is very important.
That's great. I guess they will participants will be able to find you online quite easily, so
yes,
they can
definitely
reach out to you. Yeah.
And really, the masterless data set is not included in the Randolph Glacier inventory. These are basically this is an inventory where the glaciers are, but what you can do, you have an ID of each glacier, and you find then the information in the masterless data set which glacier it is, and can then relate it to the Randolph Glacier inventory. So we all basically are within the GTNG, the Global Terrestrial Network for Glaciers, and Randolph Glacier Inventory Working Group, and the World Glacier Monitoring Service, and also the ETHA Climate Change Service. We are all in very good contact and really collaborate with each other.
Okay. Well, there's a last
how
one.
to reverse glacier. This is what we can do with WEkEO, really show how it changed, and then basically convince also the public and the policymaker to clearly show that there is something going on and climate change is happening. And what we need to do is basically reduce greenhouse gas emissions. That's very, very clear. And then this will then help to reverse the glacier retreat.
Yes,
but
you already
I can
do your
give
part. Yeah. Thank you a lot, Tobias. That was really interesting.
You're welcome. Thank you for your interest.
Yeah. So now we have our next user testimony. It's Francesca, who's a colleague of Tobias, actually. The floor is yours.
Thank you. So good morning, everyone. I'm Francesca Bardchino, and I'll be talking about using WEkEO to monitor the dynamics of the Antarctic ice sheet with a focus on the Ross Ice Shelf. So just a quick introduction about myself. So I did my undergrad in geography, and I realized that I absolutely love glaciology. I went on and did a master's in remote sensing and focused on glaciology again. And then I decided I would do a PhD in glaciology and geophysics. In my PhD, I specifically looked at the dynamics of the Ross Ice Shelf using a range of techniques, including GPS, remote sensing, and modeling, to try and understand how the Ross Ice Shelf is changing today and how it will change in the future in relation to global warming. So I'm just going to give a quick overview of why it's important to be able to monitor the dynamics of the Antarctic ice sheet. So currently, the Antarctic ice sheet holds 91% of the global ice and is therefore the largest potential contributor to global sea level rise. The largest mass losses of the Antarctic ice sheet are driven by basal melting. So the figure that we can see on the right, which has got the, I'll get a pointer. The figure that we can see that I'm pointing out on the right, which is of the Antarctic ice sheet, it's showing basal melt rates. This is actually satellite-derived basal melt rates. And we can see that the Antarctic ice sheet is split into two. We have the West Antarctic ice sheet and we have the East Antarctic ice sheet. The West Antarctic ice sheet, as we can see here, has the highest basal melt rates compared to the rest of the Antarctic ice sheet. And this is due to changes in ocean currents and ocean temperatures in the West Antarctic ice sheet, as well as the West Antarctic ice sheet's geometry means that enhanced basal melt rates here drive thinning and mass loss of the West Antarctic ice sheet at a faster rate compared to the rest of the Antarctic ice sheet. So as I said, the largest mass losses are driven by basal melting and calving. And we can see on this figure that the Antarctic ice sheet is made up of large ice shelves. So here we have the Ross Ice Shelf, which is the largest ice shelf of the Antarctic ice sheet. And we also have the Ron Ice Shelf, the Filchner Ice Shelf, the Getz Ice Shelf, and many others. So ice shelves make up 75% of Antarctica's coastline. Ice shelves have been thinning recently due to these enhanced basal melt rates. And it's really important to be able to monitor the changes in these ice shelves because the thinning of ice shelves affects the grounded ice. So on this figure on the left, we can see the dynamics of an ice shelf. So ice shelves provide buttressing to the grounded ice or the ice sheet and ice streams and glaciers. So this buttressing prevents the ice sheet from being directly in contact with the ocean currents and warming temperatures and basal melt rates. And if the ice shelf thinks, there's a reduction in this buttressing, and there's an increase in ice flow from the grounded ice into the ocean. And this results in huge mass losses across the Antarctic ice sheet. So this is the main point of interest right now for many scientists when they look at Antarctica, is trying to understand the stability of the ice shelves and how they will change in the future, because any changes in these ice shelves will affect the whole of the mass loss of the Antarctic ice sheet. So recently, in the most recent IPCC report, they indicated that global warming of 1.5 to 2 degrees will be exceeded by the end of the 21st century. And it has already been suggested that changes, that 1.5 to 2 degrees of global warming will result in ice shelves and drainage basins of the Antarctic ice sheet to collapse. We can see here in the projection figure, figure B, that using a range of greenhouse gas emissions, the Antarctic ice sheet is going to continue to lose mass throughout the 21st century. So it's really important to be able to monitor and understand the dynamics of the Antarctic ice sheet, in particular the ice shelves, today, to be able to reliably predict the changes that will be occurring at the end of the 21st century and future onwards. So I'm going to be focusing on two data sets that WEkEO provides for the Antarctic ice sheet. The first data set that I'll be presenting will be looking at velocities, so ice shelf velocities. So velocities are really important to be able to observe and calculate and measure, because they're sensitive indicators of changes in the climate. They are able to tell us what changes are occurring in the ice flow. So these changes in ice flow will be due to changes in the ice geometry, the ice thickness, the ice mass. So they really are able to give us an understanding of the changes in the mass on the Antarctic ice sheet. The velocity data sets are also really important because they're used to validate and calibrate ice sheet models. And these ice sheet models are used to provide projections of the future changes of the Antarctic ice sheet. So how velocity is measured, there's mainly two methods that are used. The first method is GPS methods, which is where you go out onto the ice sheet and you deploy GPS units, which then calculate the velocities over short temporal resolutions, so weekly to monthly timescales. However, it's quite difficult to get to Antarctica, and it's difficult to get to certain areas of Antarctica. So what's been most recently used is satellite methods, which is what I'll be focusing on here. So you can use optical or radar satellite methods. Obviously, the radar has advantages over the optical because radar can observe and measure velocities during the night and the day and during cloud cover. So this gives a more continuous data set. However, using them in combination of optical and radar provides usually quite a comprehensive data set for the Antarctic ice sheet of velocities. The WEkEO platform provides two main types of satellite data sets that can be used to calculate velocities. It provides Sentinel-1 synthetic aperture radar imagery and Sentinel-2 optical imagery. So these data sets can be processed outside WEkEO and can be used to calculate velocities using feature tracking techniques. So I'm just going to give a brief summary of some of the velocities that I calculated using the data sets from WEkEO for the Ross Ice Shelf. So on the top panel here, we can see Sentinel-2. So this is across, is quite a nice glacial outline. And then the other satellite velocity scenes are covering more of the ice shelf area, which is usually very flat and desert-like with crevasses. This data set here that I'm covering is connected to covering the Ross Island pinning point, which is an important area of the Ross Ice Shelf because this area provides stability. And then here we can see Sentinel-1 has larger satellite imagery coverage over a more continuous area. So we'll be focusing on the front of the ice shelf here. And from these data sets, we are able to see that there are seasonal changes in the velocities. So throughout these sites, which are 1, 2, 3, and 4, we can see that the velocities increase in the winter and decrease in the summer. So this helps us understand how the velocities are changing. So we know that they're changing seasonally. And now we can ask the question of what is driving these seasonal changes in velocities. So really having velocity data sets is really the first step in trying to understand the dynamics of an ice shelf on Antarctica and trying to understand what could be causing these changes in velocities. So seasonal changes in velocities could be driven by seasonal changes in environmental forcings, such as basal melt changes, which we've already touched upon previously, could also be driven by tidal changes, and could also be driven by surface air temperature changes and sea ice concentration changes. So it's really the beginning of us trying to understand the dynamics of the Ross Ice Shelf and what could be driving these velocity changes. I next touch upon another WEkEO dataset, which I quickly use to look at surface elevation changes of the Ross Ice Shelf. So surface elevation changes are really important because they provide an understanding of mass changes. So we can look at surface elevation changes and we can know if the ice shelf is thinning or thickening, or if the glacier is thinning or thickening. And this again provides us further understanding of the current dynamics that are occurring at the Antarctic ice sheet and what could be driving these changes. Also providing understanding of surface elevation changes at specific regions of the ice shelves is really important. As I touched upon before, there's certain areas of the Ross Ice Shelf, such as pinning points, which are very sensitive. So any changes in thickness or thinning here will drive changes in the overall ice shelf mass loss and dynamics. So being able to identify that changes are occurring here is also a very important question right now in the science of Antarctica. So how are surface elevation changes measured? So WEkEO provides satellite radiotimetry data, which is fantastic. And from this, you can measure ice thickness changes. And WEkEO also provides gravimetry data, which measures changes in the Earth's gravitational field over time. And this infers mass changes as well. So WEkEO has a wide range of surface elevation changes for the Antarctic ice sheet, which is really easy to download and really useful to use to try to understand the dynamics. So this is just a quick surface elevation change that I did for the Antarctic ice sheet. So here we've got the box highlighting the Ross Ice Shelf. And then here in the red box, we have the sensitive area, which is the Ross Island pinning point, where it's been shown that any changes here will result in thickness will result in changes in the overall dynamics of the Ross Ice Shelf and the mass loss of the ice shelf, which will ultimately affect the overall dynamics of the Antarctic ice sheet. So here, using the WEkEO surface elevation changes from the satellite altimetry data, we can see that the Ross Ice Shelf between 1992 and 2023 has been losing ice thickness at the Ross Island pinning point. And this helps us understand the current dynamics that are occurring and what changes could be occurring in the future if global warming continues at the rate that it is. As mentioned before, there's a wide range of other available WEkEO datasets. So Tobias already talked about the glacier elevation change. There's also a Greenland velocity map, which is fantastic. So you can download this velocity data for the whole of the Greenland ice sheet without having to process or calculate the velocities for yourself. There's nothing yet available for the Antarctic ice sheet, but I hope something appears soon. You can also look at sea ice concentration. You can look at the gravimetry mass balance data set as well for the Greenland and Antarctica. And again, as Tobias mentioned before, we can monitor these changes in ice in the cryosphere, but what is driving these changes in the cryosphere? And WEkEO provides climate data sets such as sea surface temperature and ERA5 land monthly temperature, and it also provides some projection data sets such as CMIP6 and CMIP5, which is what the IPC reports use to try and project changes in the climate and the cryosphere. So in conclusion, WEkEO provides a wide range of essential satellite data sets which can be used to monitor changes of the Antarctic ice sheet. Here's a little nice summary of what remote sensing data sets can be used to monitor changes of ice sheets. And the red stars highlights the only two missing points that I think WEkEO doesn't include. So as you can see, that WEkEO includes everything else, which is fantastic. It includes ice motion change, sea ice presence. It can include surface features, frontal dynamics, elevation change. So this is really fantastic. And as I've said before, given the inaccessibility and size of the Antarctic ice sheet, satellite observations provide the most comprehensive means to assess ice sheet change, and WEkEO really does provide the platform for you to be able to download these data sets easily and then be able to monitor changes in the Antarctic ice sheet with any kind of focus on glaciers or ice shelves. So yeah, thank you for listening. That's everything I have.
Nice final photo. Thanks a lot, Francesca. And yeah, there's a few questions for you. So the first one, do you think, from what you have seen in your studies, is it the Atlantic meridional overturning current? Is it already circulation? Sorry, is already contributing to the melting of ice sheets? I mean, maybe
So I'm definitely not an expert in that, but
Yeah.
but yes, I would say it would be contributing to the melting of ice sheets with changes in ocean currents and ocean temperatures. But yeah, I haven't specifically looked at that.
Yeah, sure. Next one, is the elevation changes data are available for high mountain Asia? Also, what about time series high resolution DEM data for HMA?
So
Not sure what that stands
this might be better for Tobias, but I do
Yeah.
think elevation changes are available for high mountain Asia, but there's no high resolution DEM data available through WEkEO. Is that right, Tobias?
Yeah, more or less, yes. So there is more available, but like what is included in WEkEO. But this is everywhere the case. Basically, we have a lot of scientists. We are publishing a lot of data, and also now make the data freely available. So there's huge data sets available, which I think in the end, the most important will make it into WEkEO, into the Copernicus Climate Change Service. But again, if you have a detailed question about what is available, what not, look at WEkEO, but otherwise you can easily find me on the web, and I'm happy to reply to you with more detailed information about what is there and what is not there.
Thanks. And for any of you, can the same methods be applied for the analysis of, okay, it's more for you, Francesca, analysis of Arctic ice sheets, or they have to be different?
So the same methods can be applied to the Greenland ice sheet. Yes, there's no Arctic ice sheet, Greenland ice sheet. So yeah, they can be exactly applied to the Greenland ice sheet. And as I said before, the velocity data sets for the Greenland ice sheet is actually all available on WEkEO. You can download it. You don't need to process it or calculate the velocities yourself. So it's actually much easier to do it for the Greenland ice sheet than the Antarctic ice sheet.
Okay.
Sorry, I think it was regarding the isostatic adjustments due to the melting of the ice sheets, where you would probably need some GNSS data, if I understood the question
Oh,
correctly.
sorry about that. I made it disappear. Oh, it's here. Restore.
So regarding this, I don't know whether this GPS or GNSS measurements are available through WEkEO as well.
Okay.
They definitely help to understand. So this is for sure.
Oh yeah, this one. You meant this one. Can this datasets help in understanding the atmospheric variations caused by melting? Okay. So next one, the glacier velocity data is available only for Greenland.
Yeah, so the calculated fully downloadable glacier velocity data is only available for Greenland, but you can download Sentinel-1 and Sentinel-2 and then calculate the velocities through some other platform, such as Sentinel-Snap, and then calculate the velocities for the Antarctic ice sheet.
The missing data you were talking about are not available only on WEkEO, or for example, there are no LiDAR satellites focusing on Antarctica at all.
So I think right now there's no LiDAR satellites, but I think there's some in the process. But the main things that we're missing in WEkEO was some grounding line dynamics satellite observation data and the velocity data sets, the fully downloadable velocity data sets for the Antarctic ice sheet, which you can get elsewhere. And if anyone wants to email me or ask me questions about that, I'm happy to help.
Yeah, thanks for that. I think we already did this one. And so last one. Again, the same. Oh, no, sorry. We already did that one. Bit lost on all this question. Oh, okay. Yeah. Glacier velocity data is available for Antarctica through NASA. LiDAR is available.
Yeah.
Okay. This was more like an information.
Yeah.
One last one for you, Francesca. Can the same analysis be applied to other planets' cryospheres? Once more remote sensing data will be available, or the in situ are too important? Well, if you have an opinion on
I
that. Yeah.
Well, I think yeah, it could be applied to other planets. I have no idea. I've never looked at other planets' cryospheres. But in situ data is important to validate, remote sensing satellite data. But the satellites are becoming more and more precise and accurate. But I do not know about other planets' cryospheres.
If I may, I can just a
Yeah.
brief reply. So certainly what we cannot have lots of in situ data of other planets, but we can use remote sensing and find some analogous landforms or features. So for example, we have some kind of rock glacier features, which we have hints of flow, which look very similar to those features on Earth. So, and these are some hints of the cryospheric presence also on other planets. So yes, we can do, but certainly we are missing in situ data, or as we have seen, it's very hard to reach the moon or other planets.
Exactly. Oh, that's interesting. Okay, thank you very much, Francesca and Tobias. So, and to finish this session, we will have Cedric Jordan. He's going to tell you a little bit more about the user component, the user support component of WEkEO. Floor is yours.
Thank you, Andrea. I would like to share, but I think you have to stop. Thank you. Up. Good morning, everybody. So I'm Cedric Jordan I'm user support manager of the WEkEO service. I'm going to, I think you can see my screen and the blue mouse. And yeah, okay. So I'm going to present you the different online resources to learn how to use data and services from WEkEO, and the different ways to contact the user support team. So there is on the online resource about the Jupyter Notebook catalog. So it's directly on the website here. So following this link, you will reach the page section dedicated to notebooks. You can sort using the different filters on the left, and then access to the notebook clicking on the title. So on the upper menu, you will find the support entry. I follow this entry. You will reach three dedicated page with three different boxes. The first one is the system status. It's not the first one, but the third one. So you will find here the different operational events impacting the production and the availability of the service, the system. And another box is a data status. Clicking on this box, you will find the status of all the datasets and products. So with the color code at the top, you click on the title, you will reach the product page on the viewer in the catalog. Come back to WEkEO. And in the third one, or the first one, the third box is the Help Center. So this section is really important because you will find here many articles to explain you how to use the data and the services. So you will find several collection with the different thematic, and inside, for example, if I follow the Getting Started with WEkEO, you will find several sub collection and explaining what is WEkEO, how to download, etc. You can use the search area here to type keywords. So you click on the title, and you will reach the article explaining how to download data, etc. So this resource, the Help Center, is really useful, and I suggest you to check if the answer is not available in this Help Center before asking to the support. But of course, you can ask, but everything many things are available in this resource. So to to contact the support, there are 3 different ways. In the support page here, so there is a form to fill in with your name, mail, and the message, and you can send your message, and the user support team will be informed automatically. Then, of course, you can send us an email at this address, support@wekeo.eu. The same, the email will reach the user support team, and at the bottom right of the page, all the pages, you will find this icon. You click on the icon, and you will it is a chat to contact us. You can, of course, send us a message, and you can always as well reach the help center with the same functionality. If I want to, like, we can type a keyword. You can here there is a help section. You can find the different collections, the same thing. So here you will find the same article than in the help center. So if the answer is not available here, you can contact us. Send us a message, or directly here, send us a message. You click, and you will emit a member of the team, so Alexander or another member of the team, and we'll answer you as soon as possible. And so, but we answer rather quickly, so do not hesitate to if you have any question on anything. If we don't have the answer, we will find the right people in the WEkEO team to answer you. So that's all for me. Thank you very much.
Thank you very much, Cedric. And with this, we are almost done with today's session. I'll just share with you our agenda for tomorrow. So today we had an introduction session on WEkEO. You could see what is WEkEO about, what kind of data sets can you find there related to the study of cryosphere. And tomorrow is going to be a more practical session. We will have Alexandre Bauch, who's going to do a demonstration of the viewer. It was briefly mentioned today. You will see how to visualize the data that is available on WEkEO. And then we will have Alexandre Meran and Daria Andreevskaya, who's going to show you some very interesting tutorials on both Jupyter notebooks and using QGIS software. And with this, we will conclude today's session. I hope this was interesting for you, and don't hesitate if you have any other questions. Our speakers were quite okay with you contacting them if you have any specific questions. Presentations will be sent to you as well via an email, and the recordings of today's and tomorrow's session will be available on the WEkEO YouTube channel. And now if you could just take a few seconds before you leave our session to answer a quick survey we've done. I can share my screen, and on Slido you will find a little, yes, sorry about that. So you'll be able to stay a bit around, and if you could just answer our survey, that's really important for us to help us improve our formats, our content of our workshops. So please stick around. And thank you all for your participation, Tobias, Francesca, Cedric, Christian. Thank you, all of you, for your contributions. It was really interesting.
You're welcome. Thank you for inviting us.
Of course.
And thank you for all the questions.
Yeah.
We had quite a few questions. Quite interesting questions. Thanks a lot.